Welcome to the first chapter. In this chapter, we're going to be covering an example hardware setup for a multi-copter drone running ArduPilot. Now, depending on what type of drone you are going to be working on, your hardware may look very similar to or very different from the hardware in this example. That said, the functional elements are likely to be similar. Motors, ESCs, flight controller, GPS and camera systems are all common across the vast majority of ArduCopter drones, and so it's likely that these functional units will also be present in your drone. Regardless of what drone you're tuning, this example hardware setup also provides a low-cost hardware setup that could be built or copied for a training drone to teach pilots to fly ArduPilot or to tune ArduPilot. And so if you are looking for a design for training on, then this example hardware setup would be a good place to start as well. With that said, let's dive into the hardware. Before we dive into the wiring and setup, I just want to take you through the hardware that I'm going to be using on my test drone for this tuning guide. And it's hardware that you're probably very familiar with if you've ever built and flown an FPV drone before, or you've done anything with hobby drones in general. We're going to be using the AOS UL8 frame. This is a lightweight general purpose 8-inch frame. It's perfect for acrobatic flying and autonomous navigation. We're using it with the Maytech H7A3 flight controller, but you can use any flight controller with an ArduPilot target. We're using a standard 30x30 4-in-1 ESC. This is the iFlight Blitz E55. We're using an M10 GPS and compass module. And it's important when picking a GPS module for ArduPilot that you make sure that it also has an integrated compass, because ArduPilot really does need a compass. We're using an Express LRS 2.4 GHz receiver and a DJI O3A unit for video. But you could use a different video system like DJI O4, walk snail, analog, anything you want really, that will work just fine. Now that we've got our hardware together, it's time to start wiring it up. And wiring from the flight controller to the ESC is very important. If you have not bought a stack, that is a flight controller and ESC that are designed to work together, then you must carefully check the pinouts of both your flight controller and ESC to make sure that they match up. Some combinations will apply reverse polarity to your flight controller and burn it out on first power up. I've had this happen. I know other people have had this happen. It's very upsetting. Let's, for example, look at the Maytech flight controller, the H7A3, and the iFlight ESC. You can see that the pinouts here don't match at all. And if I was just to plug one plug into the other, I could apply full battery voltage onto my signal pins and burn out my flight controller right away. Fortunately, if the pinouts don't match, then you can repin the JST 1.0 plugs using a pair of tweezers. I'm going to show you how to do that now. So let's say we found ourselves in the situation where the power and ground pins on our flight controller pinout were reversed from the ESC. Well, what we can do is if you take a pair of really sharp tweezers, you can just very gently lift the plastic tab in the JST plug. Now you don't want to bend this back too far because you don't want to break it, but you just want to lift it a little bit. And then if you just lift it the right amount, you'll be able to pull the wire out of the plug, just like that. And we can do the same for the pin next to it. And then we can just swap them round and put them back in the reverse order. So I'm going to put I'll do the red one first, that'll be easier. Once you've pushed the two wires in, just gently with a nail press those little plastic tabs back down. And what you've done is you've effectively repinned the plug. So now we have the red and black wires reversed. Wiring from the flight controller to the GPS is really quite simple. If you've bought a combined GPS and compass module, you'll have 6 wires to connect, and you'll want to connect SCL on the GPS to SCL on the flight controller, SDA to SDA, TX on the GPS needs to go to RX on the flight controller, and RX on the GPS needs to go to TX on the flight controller. So the UART pins are swapped around like that. And you also need to connect the ground and the 5-volt wires. I would suggest that if your flight controller has 5-volt pins, which will power up when you plug in a USB, then those are the ones that you should use to power the GPS and the receiver. We'll get to that in a second. It's just so much easier if the GPS powers up over USB and you don't need to plug a flight pack in. On the Maytec flight controller, those are marked 4V5 to indicate that they'll power up from the USB. Make sure to make a note of the number of the serial port that you've wired the GPS to. So in my case, it's going to be RX3TX3, so the serial port number is 3. Wiring up the receiver is even easier. All you need to do is pick a different serial port. So in this case, I'm going to be using RX2 and TX2. Wire up the receiver TX to the flight controller RX and the receiver RX to the flight controller TX, and then also wire up ground and 5-volt. And again, I would use a 5-volt pin that is going to power up when you plug in USB. So on the Maytec board, it's marked 4V5. Rather than a 5-volt pin which only powers up from battery voltage. It's just so much easier if all of your electronics is up and running when you plug in USB rather than needing to plug in a flight pack all the time. Again, make a note of the number of the serial port that you're using for the receiver, and in my case, that's number 2. Wiring up the air unit is also pretty simple. Just pick another serial port. I'm using number 6 and wire up TX on the air unit to RX on the flight controller and RX on the air unit up to TX on the flight controller. And then for power, you can either use an onboard BEC if your flight controller has one. So I'm using the 9-volt BEC on my Maytec board for the O3 air unit. Or if your air unit supports a wide enough voltage range, you can run it directly off battery voltage. But do just double check that the maximum voltage of your battery is less than the maximum supported voltage for your air unit. Once you've done that, make a note of the serial port number for the air unit because we'll need that later. If your flight controller has an RGPilot target but doesn't come with RGPilot flashed onto it, perhaps it comes flashed with Betaflight or another flight controller firmware, then you're going to need to flash RGPilot yourself. Fortunately, that's pretty easy to do, and I'm going to talk you through it. The first thing to do is to go to firmware.rgpilot.org, link in the video description, and scroll down to Copter for multicopters, and then you're going to want to look for the latest folder. Inside latest, just scroll down and find your target. So I know mine is the Maytec H7A3, so I'm going to click into there. And you can see that I have a few options. I want RGCopter with bootloader. So you want to make sure you have the bootloader included with your firmware file because that's going to allow you to update to future versions of RGPilot without needing to reflash the whole lot. So make sure to pick the RGCopter with bootloader hex file and download that to your computer. You're also going to want to download and install the STM32Cube programmer software if you don't already have it, because that's what we're going to be using to flash the RGCopter with bootloader hex file onto your flight controller. Now you need to put your flight controller into bootloader mode, and this is really quite easy. Find the boot button on your flight controller, so mine is just here. Press the boot button down and then plug in the USB cable. Then you can release the boot button and the flight controller is in bootloader mode. Once the flight controller is in bootloader mode, head on into STM32Cube Programmer, go to this blue menu and select USB, and then hit this refresh button here to update the ports, and you should find a port USB 1 with the serial number of the STM32 micro that is connected on your flight controller. If all that's working, hit connect, and you should come up with a load of data here just showing you what's on the chip right now. Obviously, we want to reflash the chip to RGPilot, so we're going to go to the erasing and programming menu, and we're going to do a full chip erase. This is going to wipe everything that's on the flight controller right now and get it ready to take RGCopter. So we're going to click this full chip erase button and it will give us a confirmation, and we just hit OK to wipe everything on the chip. Once everything has been wiped, you're going to want to select the new firmware path. So go and choose RGCopter with bootloader that you just downloaded, select that. Make sure to tick verify programming and run after programming. And then you can also tick full chip erase, but we've already done that. Once that's all done, hit start programming, and that will reflash the chip with the RGPilot firmware. Once that's complete, just unplug and replug the USB to power cycle the chip. To check that the firmware flash has worked, plug the flight controller back into your computer, open up Mission Planner and go into the top right, set the port to auto and hit connect. With any luck, Mission Planner will be able to connect to the RGPilot firmware running on your flight controller, and you'll see Mavlink connecting followed by getting parameters. If you see this, then everything is working correctly and you can move on.